Hello everyone, welcome to today's class. We'll be starting with a new topic called planes. This is a subsection of 3D also. So we'll be looking at the equations of plane, types of different form for writing the equations, then angles between them, distance of the plane, okay, from a point. Those kinds of things we have to look forward to. Let's start with the basic. First of all, I'll introduce the general form of plane, the general equation that will be usually given to you. So any equation of a plane will be in this form. Ax plus by plus cz is equal to d. Okay. ABC are some coefficients. All right. Okay. This is just an idea. Then the first form is equation of a plane in normal form. Okay. Again, we'll be looking at two forms, Cartesian as well as your vector. Okay. Of course, the vector will be easier, but it's just that in the case of planes, mostly equations given is in the form of Cartesian. Still, both are pretty much equivalent this time. So first of all, what is given in this situation? Let's consider a figure. Okay. All right. Let's say you have a plane like this, okay, and there is a point on the plane that is at x comma y comma z, okay, any random point, okay, and the position vector is represented by r, okay, and you drew a perpendicular from the origin, okay, the perpendicular is from the origin, and you calculated its distance is d, okay. So in this normal form, what is given is, you should know what's given to us. The given thing is d, which is, remember that this d is distance from origin, okay, and we are given n cap. What is n cap? See, n is normal vector, n cap is unit normal vector. Okay, unit normal vectors are important. So the form goes like this. The vector form is r dot n cap is equal to d. A very simple form. Okay. All right. Since n is a unit vector, okay, so its component will be as such. What is a component of unit vector? Usually we say they are direction cosine, okay. So your r vector in general, it is x I cap, y j cap, z k cap, okay, that's your r, okay. Your n cap vector will be some l I cap, m j cap, n k cap. Why I'm writing lmn? Why not abc? Why not n1, n2, n3? Because components of unit vector is direction cosine, that's why I'm writing lmn. That's it, okay. Actually it will be given to you some value, but you should know that those are direction cosines, okay. So if we literally multiply this, okay, if we do the dot product of r dot n, what do we get? Lx plus my plus nz is equal to d, okay, and this is the Cartesian form of plane, equation of a plane in normal form, okay. Lx plus my plus nz is equal to d. What are lmn? Let's write down that also. Lmn are components of n cap vector, in bracket direction cosines, basically. Okay. So sometimes the question might use this idea to confuse you, that the direction cosine of the normal vector, Okay, the direction cosines of normal vector. The moment he say direction cosines of normal vector, you should know he is talking about LMN. It's as simple as that. Let's use it and let's understand one concept with the help of an example. All right. Look at this question. So the question says find the vector equation of a plane which is at a distance of 6 by root 29, okay, from origin. So that's your D, because it's distance from origin, then it's D, okay, and it's normal form vector. So he's saying normal vector, not n cap. Otherwise he should have said unit normal vector. Its normal vector is this. He's saying find the vector equation, also find its Cartesian form. All right. Let's write on the, first of all, vector form. Vector form is very direct. R dot n cap is equal to D. But the problem is we are not given n cap, we are given n. So let's modify this. R dot n cap. How will we get n cap? This is our n vector. Na? How will we get n cap? The vector divided by its magnitude. So the vector n 2i plus minus 3j plus 4k divided by its magnitude. What's the magnitude? Square root of 2 square plus minus 3 square 4 square is equal to 6 by root 29. Okay. So r dot, this becomes 2i minus 3j plus 4k, okay, upon square root of 2 square is 4 plus 9 plus 16, 16, 9, 25, 29. It's also coming 29, root 29, 6 by root 29. So fine, root 29 cancels. So the equation is r dot 2i minus 3j plus 4k is equal to 6. That's your answer in the vector form. Now, in order to convert this into Cartesian form, again, no need to learn the form exactly, that it is Lx plus my plus nz is equal to this. If you know the vector form, you can convert it. All you need to know is r vector is in general point xi plus yj plus zk. You put the value of that and you do the dot product. That's it. No need to learn it. So that's vector form. So now, in order to put the Cartesian form, xi plus yj plus zk. Okay. This is only one time. After this, I'll teach you the shortcut and you'll be able to write this very much directly. Sorry. Dot 2i minus 3j plus 4k is equal to 6. Let's do the dot product. So I with I, 2x minus 3y plus 4z is equal to 6. This is the Cartesian form, and usually the question will ask this form. Okay. Or the question will be given in this form. I'm not saying they cannot give in vector form, it's just that it is more preferred. Okay. Now if you look at the component of x, the component of y, the component of z, this is 2 minus 3, 4. Aren't this the same values as 2i, 3j, 4k? So what can we interpret? In this in any equation of a plane, the component of x, y, z are the components of normal vector. So direct conclusion by comparison. Okay. So star point, components of x, y, z in equation of plane are normal vector. I'm not writing components of normal vector, let's keep it short. It's our normal vector. So for example, I say a random equation 7x minus 2y plus 4z is equal to 17, something like this, and ask you find its normal vector. So the moment you see this equation, you can say I know the normal vector of this. The normal vector is 7i minus 2j plus 4k. Just introduce ijk instead of xyz. That's it. All right. That's the first concept. Second thing, what if the equation is given and he asks what is the distance from origin? Okay, so I'll take the same question. We know that the distance is 6 by root 29. So let's see. So suppose the equation was given. Distance from origin. Okay. As such, it's just an observation. But let's, for example, consider the same equation. That's 2x minus 3y plus 4z is equal to 6. You know, the moment you see this, you know the normal vector is 2i minus 3j plus 4k. Now you already can see this. By just looking at this vector, you know this is not a unit vector, because the moment you do square root of 2 square, 3 square, 4 square, it will not come 1. So that means it's not a unit vector. Just by observation, not a unit vector. You know, in order to get distance from origin, you should have normal vector, unit normal vector, I mean. Okay, you should have unit normal vector. So in order to get the unit normal vector, what do? We divide the n vector with its magnitude. That means if I directly want, see, clearly remember that this is not d. This is not the distance from origin. This can be interpreted as a variable d, but this is not the distance from origin. This can be distance from origin only if the components were a unit vector. So in order to do that, what I'll do is I'll divide both sides by magnitude of n vector. If I divide it, what do I get? 2x minus 3y plus 4z. Divide the equation of plane, okay? So 4z is equal to, the magnitude we already calculated for this one. Magnitude was root 29 and this was also root 29, okay? Just to get the distance from origin, now I can say, because I have divided by its n vectors magnitude, that means this will be now components of a unit vector. That means now I can say this is the distance from origin. So in order to get the distance from origin, what's the key idea? Divide, I'll modify this, divide the equation of plane. Okay. Divide equation of plane both side by magnitude of n vector. N vector you can already guess now. Okay. That's only the key thing that you should remember. Okay. All right. Okay. Let's see another equation. They'll only confuse you regarding the language. As such, this first concept is very simple. It's just that you have to understand when you have to take a unit vector, when you have to take the n vector. Okay. And this is the only concept that will require this. Whenever the distance from origin is asked, that means you have to understand that you don't need n vector, you need n cap. Okay. Look at this question. He's saying find the direction cosines of unit normal vector. Even if the question was not saying direction cosine, we know that its components are direction cosines. Okay. So even if this word was not mentioned, the question still remains the same. To a plane, this passing through origin. Okay, fine. Find the unit direction cosine for unit vector perpendicular to the plane. Okay, so perpendicular to the plane. So when the problem is the analysis is sometimes difficult. So just for your simplicity, I'll show you how the normal looks like on a plane. Normal means 90 degree to a plane. Okay. So it will be like this. Okay. Now it's in 3D, remember that. Okay. It's like you take a stick and put it in the ground vertically. That's your normal vector. Okay, fine. So this is the equation. Okay, all right. We need direction cosine. So we already know that this form r, if I take 1 on the other side, r dot 6i minus 3j minus 2k, that's equal to minus 1. Okay. Equal to minus 1. This form can say that this is the n vector. But could it be n cap vector also? No. We have to check it ourselves. This can be n also, or this could be n cap also. Okay. The point is either the equation, the coefficients of x, y, z, that will be your n vector, or whatever is in the dot product of r, that will be your n vector. So clearly I can see 6 square plus 3 square plus 2 square, definitely not 1. So that means in order to get the unit vector, what do I have to do? This is n vector, so n cap is divided by magnitude. So 6i minus 3j minus 2k and divided by its magnitude. Magnitude is 6 square 36, 3 square 9 plus 2 square 4, 40, 49, 7. So basically 6 by 7 I minus 3 by 7 j minus 2 by 7 k. But you know how the answer would be written. Since it's asking for direction coordinate, they will be written like LMN. So this is L, this is M, this is N. Okay, so the answer will be written like L comma M comma N. That's 6 by 7 comma minus 3 by 7 comma minus 2 by 7. Okay, so the representation of answer is slightly different. That's it. Basically, if you put ijk, that's a vector. If you don't, that's your cosine. Okay, all right. Next question, again same idea. Is asking you, has given you the equation and asking for distance from origin. The moment you see distance from origin, just use the concept. What is the concept? That these are n vector, components of n vector, and if we take this 6 to the other side, the equation will look like this: 2x minus 3y plus 4z is equal to 6. Now point is this the distance? No. This can be the distance only if this was a unit normal vector. I think we discussed the same one, na? Yeah, same one we discussed, na? So in order to get the distance from origin, what we have to do? We have to divide both sides by same thing. So they have also created the same question that I already discussed. So that means in order to get this distance, I have to divide by its magnitude. So 2 square 4 plus 9 plus 16. So that is same as root 29. Okay, so you have to divide both sides by root 29 to get the distance from origin. Now you can say this is distance from origin. Same question again. I didn't expect that. All right. Okay, so that's done. Now there are certain other forms also. Let's look at the other forms. Next form is equation of a plane perpendicular to a given vector passing through a given point. So this time a point is given and perpendicular to a given vector is also given. Okay, so perpendicular to a given vector. If perpendicular is given to a plane, that means he has given you the n vector. Okay, I need the diagram. One second. Diagram. All right. So first of all, you have to understand what is given. So in this situation, what's given to us? Given is the perpendicular vector. That means normal vector is given, and passing point. So passing point will call as a vector. Okay, the coordinate will be the point of this will be x1, y1, z1. Let's say we already know how to convert this into a vector. Just put ijk. Okay, so the form is r minus a dot n vector is equal to 0. This is the form. Okay, r minus a is equal to r minus a dot n. If you want the Cartesian equation, what you do, you put the values of r as x I cap, y j cap, z k cap. A you already know. Okay, and then you do the dot product with n vector. You'll get in the Cartesian form. So no need to separately learn Cartesian form. Okay, but if you want to learn, you can learn this. Okay, but my recommendation, don't learn it. Okay, this is the vector form, this is the Cartesian form. Okay, basically he is considering n vector as a I cap, b j cap, c k cap. Okay, for this you have, if you are learning this form, you have to learn that n vector is a I, b j, c k, and your a vector or the point a. Okay, passing point is also a, na? So this is where the confusion becomes. If you try to learn both the forms, a, b, c, these are being repeated and they have all different meanings. Okay, so that's why I recommend to learn it with the vector form, because notations are short. Okay, passing point is x1, y1, z1. Okay, components of a vector. So I've shown you this, but learn this only. If it is required to for the Cartesian form, we'll convert it using the same idea. We'll see. Let's see a question. Won't take too much of a time as such. If you understand the concept, it'll be fast. Find the vector in Cartesian equations. So for this, passing point is given perpendicular to a line. Okay, so perpendicular to a line, vector equation of plane passing through this and perpendicular to a line. So plane and line are perpendicular. Okay, so if you want to look through this again, so let's say this is the plane and this is the line. Okay, they are being perpendicular. That means indirectly, directly, he is giving us n vector, and he is saying direction ratio. What are direction ratio? Again, the word is just to confuse you. Direction ratio means components of n vector. Direction cosine means component of n cap vector. That's it. The only difference. Basically, he is again saying that this, just put ijk with it, you will get your n vector. Okay, let's write down the vector equation. R vector minus, this is a vector, na? So I'm putting ijk with it. So R minus 5i minus 2j minus 4k. Okay, dot n vector is 2i minus plus 3j minus k is equal to 0. That's vector form. Okay, no need to do anything else. Actually, you can do slightly. What you can do is take one more step. What you can do literally dot product. Dot product can be distributed. So we can do dot product of these two vectors actually. So let's do dot product. So it will be r vector dot 2i plus 3j minus 6k. Okay, and let's do the dot product minus the dot product of these two, 5 to 10 minus 6 plus 4 equal to 0. So r dot 2i plus 3j minus 6k, okay, is equal to what? 4 plus 4, 8. Okay, that's the final answer for vector form. If I want to convert into Cartesian form, what do I have to do? Replace r with xi, yj, zk and do the dot product. Okay, so if I do the dot product, what will I get? Basically this components with xyz, 2x plus 3y minus 6z. Just replace ijk directly with xyz is equal to 8. So how much time would that take? As long as you can do the Cartesian form, the vector form is simple. Okay, so no need to learn this Cartesian form separately. But suppose you are getting confused with this method, do learn that. Additional formula is there, you can learn. Okay, so just put the value of r here. Okay, I have done directly. Okay, put the value of r, do the dot product. So I will be multiplied by, so 2x 3y minus xz. Now that I have understood that, I'll directly do this. Just replace ijk with xyz in the vector form. So direct shortcut. All right. Next form. So there are forms effectively. You have to go through all the forms. Next form is equation of a plane passing through 3 non-collinear points. Okay. So from 3 points, we can make a triangle. That triangle itself is a plane. So that's the idea. I'll not show the figure. There is no need for that. It will only complicate things. Okay. All right. Just I'll make one simple figure like this. Let's say you have 3 points A, right? Okay. B, C. These are points. The coordinates will be x1, y1, z1, something like this. The point is their position vector is A vector, position vector is B vector, position vector is C vector. Okay. So the form looks like this. You have to learn this. R minus A cross B minus A cross C minus A. A lot of cross. Okay. I think misinterpretation is there. Sorry. There's a misprint in the book. I'll write the formula. The formula is R minus A dot B minus A cross C minus A is equal to 0. So first you do B minus A, C minus A, do the dot product of it, and then do the cross product of it, then do the dot product with R minus A. I'll tell you what the whole idea is. The whole idea was, if you look at this, R minus A, this is like n vector. Okay. Because if you know the passing point and you know the normal vector, so indirectly or directly, this is the normal vector of the plane. So if you want to get the normal vector, all you have to do is B minus A, C minus A. And you don't literally need this B minus A, C minus A. See, what is B minus A vector? If I take B minus A vector, that's AB vector, right? If I do C minus A, that's AC vector. Okay. So what's actually AB cross AC? What does a cross product give us? Let's go to the basics of vectors. What does a cross product give us? A vector perpendicular to both AB and AC. And try to think, if something is perpendicular to both AB, AC, wouldn't that be your normal vector? Just look at this. Right now I have drawn this in 2D. So a vector that is perpendicular to both the vector, it will be like something is coming out of this point A towards you, out of the screen of your laptop or phone. Okay. So that will be your n vector. So remember that n vector can be given by the cross product of any two vectors in the plane. It's not necessary I have to take AB and AC. I can take AB BC, BC AC, BC CA, anything. So this order is not important. Whether you do C minus A, B minus A, doesn't matter. Whether you do it B minus A minus B, doesn't matter. So suppose you mess up the formula, so you are unable to recall what was the actual formula, you will still get the correct answer. All you have to do is just get two vectors, any two vectors, AB, AC, BC, anything. Okay. In this question, they have taken AB and AC, but sorry, in this form they have taken AB and AC, but it's not a condition. Literally, you can get the same vector from AB cross BC also. Okay. Or AB cross AC already run, BC cross CA AC, one or same thing. Okay. That means this Subtraction order doesn't matter. This subtraction order doesn't matter. The cross product itself order doesn't matter. You'll still get the correct answer. And also, you can change this a. This is r minus a, na? It's not necessary that you have to write r minus a. You can write r minus b, r minus c also. Still, you get the same answer. So no matter how much you want to mess up this formula, this will give you correct result. All you have to do is just find the two vectors in the plane, do the cross product of it, and then use this form r minus a dot n. Okay. But students have the tendency to learn this because this is in order as such, so they can learn this easily. But I'm just saying that in case you ever forget this, no need to worry about it. This is the vector form. The Cartesian form, again, my recommendation, don't learn it. I'll show it, but I'm recommending don't learn it. Learn only this. The Cartesian form is just lengthy. This is the Cartesian form. Okay. So the coordinates, right? They are writing a is actually your x1, y1, z1. B is your x2, y2, z2. C is your x3, y3, z3. Okay. So if you can learn this, do learn it. I have the tendency to prefer for this one. I teach my students like that. Okay. Let's see one question. Okay, the question. You have 3 points. Okay, so you have your 3 points. Although names are given R, S, T, doesn't matter. Let's call this as A, let's call this as B, let's call this as C. What do I need? First of all, in order to avoid any error, do B minus A first. Do C minus A first. Okay. So B minus A. That's minus 2 minus 2, so minus 4i, minus 3 minus 5, minus 8j, 5 minus minus 3 plus 8k. Okay, then do c minus a, so 5 minus minus 2, 7i, 3 minus minus 3, 6j, minus 3 minus 5, minus 8k. Okay. Sorry, C minus A I had to do. I did by mistake. I did C minus B. Although still I would have got the correct answer even if I did the cross product of that. I told you that. All right, let's do C minus A. So 5 minus 2 is 3i. 3 minus 5 is minus 2j. And minus 3 minus 3, that becomes 0. So one good thing is we got 0. All right. Now let's calculate the cross product first. B minus A cross C minus A. Basically I, J, K. Your B minus A vector components first. So minus 4, minus 8. Minus 4, minus 8, 8. Then 3, 2, 0. Determinant of it. And expand along this. So I into 0 minus 16. So minus 16i minus j, okay, plus minus plus. So minus j, leave this row column for j. Okay, you should know this if you have done the determinant. In case you have not, go through the determinant lectures. Minus, this is minus 4, 0, minus 24. And k is also plus k. That's for that we have to leave the first row and third row and third column. So that's minus 8 plus 24, so plus 16. All right, big numbers. doesn't matter. Now let's rewrite this. Minus 16i plus 24j plus 16k. Okay. Now I have to do write the vector form effectively finally. What is that? R minus a, and remember that this is your n vector. This is your n vector. Okay, so R minus a dot b minus a cross c minus a. Okay, this is for your understanding that this effectively is your n vector is equal to 0. This is the form. So R minus a is minus 4i minus 8j plus 16k. Okay, and the dot product minus 16i plus 24j plus 16k is equal to 0. Big values, so sorry. So let's do the dot product. Dot with this, r minus. So one is r dot minus 16 plus 24 plus j plus 16k. Okay. This minus the dot product of these. So minus plus 64, 24 and 8. 8 64 into 3 now. So 180 and 12, 192 minus 192. Okay, plus 16 is 256 is equal to 0. Let's recheck. That's minus 16 4 64, 24 and 8 83 64 into 3, 180 plus 12 192, correct, plus 256. Okay, so it is coming r dot minus 16i plus 24j plus 16k, okay, is equal to, take it on the right side, it becomes how much? 192 256. So this is 60 263 20 minus 192, that's 8, okay, 11 2 128. We could have taken 16 or 8 common from the starting and reduced this. Okay, what we could have done here, that we could have taken here 8 common, that would have given us the reduction and the calculations would have been lesser. Take 8 common and take it on the right side, that becomes 0. Because still you can do is like 16 24 16 na? So you can still take common and effectively it cancels this 128. So I'll do that. So if I take 8 common out of it, r dot minus 2i plus 3j plus 4k is 128. So that's r dot 2i minus plus 3j plus 4k is equal to, this is 1 6. That's it. That can be your answer. If he wants the Cartesian form, suppose he asks for Cartesian form, now I'll not take even like 10 seconds to write this. What do I know? That r is xi yj zk. So when I do the dot product, just replace this ijk with xyz. So minus 2x plus 3y plus 4z is equal to 16. That's a Cartesian form. So barely 10 seconds to convert vector form to Cartesian form. Just put xyz. All right. Next form is intercept form of plane. It's like intercept form of the line, if you can recall it from the straight line concept. Okay, what is the intercept form of line? Okay. It was like x I cap, y j cap, z k cap. Okay, sorry, my bad. It was x upon a, y upon b is equal to 1. So the line would cut at x-axis and y-axis at a and b. Pretty much same idea. If you'll see the form now, you'll be surprised that this is exactly same, just in 3D, and now it represents a plane. This is the formula. So if you have a plane which is intersecting x-axis, y-axis, z-axis at a, b and c distances. Okay, so it is intersecting at a distance, it is intersecting at b distance, it is intersecting at c distance. So you'll directly write x upon a, y upon b, z upon c is equal to 1. Okay, and suppose what they do is they ask you where the plane will intersect rather than this. So what you do, you make the right side 1. Okay, we'll discuss these questions in the later. We'll discuss all the problems of planes. Okay. So this is the just form, simple enough. Next is the important one, equation of a plane passing through intersection of two planes. Okay. So there is a possibility that two planes can intersect. I mean, two lines can intersect, so the two planes can also intersect. So it will be something like this. Two planes are intersecting, and we have to write equation of a third plane which is passing through their intersection. So how this form goes is, again, I'll write it in my way, and we'll do in vector form only, not the, we can do in the Cartesian also. Both forms are simple. I'll give you the idea. First of all, what is given? Two planes are given. Okay, first plane equation, plane 1, it will be given by r vector dot n1 is equal to d1. Okay, another plane equation, r vector dot n2 is equal to d2. That's a vector equation. Or in the Cartesian form, it will be like a1x plus b1y plus c1z is equal to d1. This will be a2x plus b2y plus c2z is equal to d2. Okay, so either they will be in the Cartesian form or in the vector form. Okay, so the idea is, the new equation of plane is p1 plus lambda times p2. That's it, just remember that. What is lambda? Lambda is some parameter. Again, different values of lambda means different planes this time. Okay, so the first form looks like, vector form will look like r dot n1 plus lambda times n2 is equal to d1 plus lambda times d2. Okay, r remains the same, whereas the Cartesian form looks like this: a1x plus b1y plus c1z. So don't need to learn the whole format, just learn first plane equation plus lambda times second plane equation plus a1 plus c1z. This is the first plane equation plus lambda times second plane, a2x plus b2y plus c2z is equal to d1 plus lambda times d2. Now if you want to learn these long forms, again, your call. My recommendation, just learn p1 plus lambda p2. Okay, this is the key. And you look like, it look like, this is the first plane equation plus lambda times second plane, d1 plus lambda times d2. All right, done. Now let's see a question how that is helpful. So the questions again directly says that you need to find equation of a plane passing through the intersection of two planes. This time he has given in the vector form. Good enough. and he is saying equation of plane passing through intersection of this and this, means the plane also passes, the new plane passes through 1 comma 1 comma 1 also. For this particular form I'll recommend for the Cartesian form, because I'll have to put the values. Convert this into Cartesian form. Again, less than 10 seconds. What do? Just put, instead of ijk, put x, y, z. X plus y plus z is equal to 6. Direct. Cartesian form. 2x plus 3y plus 4z is equal to minus 5. Direct. Now, the equation of new plane that is passing through the intersection. What was the idea? P1 plus lambda times P2. So let's put the values. P1 x plus y plus z plus P2 is lambda times, so we have to put lambda before P2, lambda times 2x plus 3y plus 4z is equal to, first plane was right side 6 plus lambda times minus 5. So basically minus 5 lambda. Okay, that's the new equation of plane, and the question is saying that this point is lying on this plane. That means this must satisfy this equation of plane. If that satisfies this equation of plane, I can put x, y, z with 1, 1, 1. So 1 plus 1 plus 1 plus lambda times 2 plus 3 plus 4 is equal to 6 minus 5 lambda. This will give me the value of lambda. The moment I get the value of lambda, I'll put it in this equation, new equation, and I'll get the required equation of the plane. So in order to get any particular equation of plane passing through, you have to get the value of lambda, and he will the question will give you some sort of condition to get the value of lambda. Right now they are saying it is passing through the intersection of, sorry, the plane is passing through this 1 comma 1 comma 1. So this must satisfy this. So 3 plus 4, 3, 7 to 9 lambda is equal to 6 plus 5 lambda, sorry, not plus, minus 5 lambda. So that's 9 plus 5, 14 lambda is equal to 3. So lambda is equal to 3 by 14. Weird value, but yes. Anyway. Okay. Now that we get the value of lambda, you put it in the equation. So what is the equation? So the equation is x plus y plus z plus lambda times, lambda we know na, how much, plus 3 by 14, 2x plus 3 by, what I've done is, this was the new equation, so I'm rewriting this with lambda value. X plus y plus z plus lambda is 3 by 14. I've used the value of lambda here, plus 2x plus 3y plus 4z is equal to 6 minus 5 into 3 by 14. Just combine the equations, you'll get the new one, how much it is getting. Okay, so 14, so this gets 7, 3 by 10 plus 7, sorry, 3 by 7 plus 10. So this will become 10 by 7x plus 9, 14, 23 by 14y plus 14 plus 12, 26. So no, 7, let's do 7. So 7, 26, so 13 by 7. Z is equal to, the right side will be 14, 15, 14 into 6, 60 plus 24, 84 minus 15, that's 69 by 40. Okay, so if I again recorrect this with the 14 base, it is 20x plus 23y plus 26z is equal to 69. Okay, just take the LCM 14 and 14 cancels. And suppose the question was actually asking for vector form. Now in order to write the vector form, that just replace your xyz with ijk. R dot 20i plus 23j plus 26k, because that's your n vector. Okay, component of xyz is n is equal to 69, and that's the vector form. This is the vector form. This is also the answer in Cartesian form. For this kind of question, my recommendation, go for the Cartesian form rather than vector. Okay, both are pretty much the same. It's just that whenever you have to literally get the value of lambda, you will required to convert into the Cartesian form. It will be much more simpler that way. Okay, so some form is better in some particular format, some is other. All right, let's just cover the formats and then we'll do the questions later. Let's finish the formats first. Coplanarity of lines. So remember we discussed skew lines, the lines which were not even parallel but still not intersecting. The problem was they are in 3D. Now there is a possibility that two lines may lie on same plane. Okay, so what is the equation of a line? So the equation of a line, remember, r vector is equal to a1 plus lambda b1. Okay, a is the passing point, b is the direction. R vector is equal to a2 plus lambda mu b2. Okay, some constant mu. Okay, a is the passing point, b is the direction. This is your line 1. This is your line 2. Now you have to get the condition for the lines to be in the same plane. In that scenario, what do? You have to write a2 minus a1 vector, okay, dot of b1 cross b2. If that happens to be 0, the lines will be coplanar, otherwise no. Okay. Condition of coplanar lines. Okay, so again equations will be given, you will be able to identify ABC, and that's it. Again, learn only the vector form. This is the vector form, and learn only this. Don't go for Cartesian. Again, lengthy form. Let's look at one example. So this is a line given. All you need is a vector, b vector identification that we have done in lines. The values in the numerator with change sign is a. The values in the denominators are b. So a vector, a1 vector is, change the sign, minus 3i plus j 1j plus 5k. a2 vector, change the sign, minus 1i plus 2j plus 5k. b1 vector are the denominators, so minus 3i plus 1j plus 5k. b2 vector is minus 1i plus 2j plus 5k. He's asking they are coplanar or not, so you will have to check the condition. So calculate your a2 minus a1, do the dot product with b1 cross b2. So you need to calculate b1 cross b2 first. I'll teach you one direct way that actually is in the Cartesian form, but I'll teach you how to convert and solve this in one go. So calculate your a2 minus a1. a2 minus a1 is minus 1 minus 3, so minus 2i, 2 minus 1 ij, 0k. Okay, all right. Then you have to do dot product with cross I, j, k. Okay, then b1 is minus 3, 1, 5, b2 is minus 1, 2, 5. You have to check whether this is 0 or not. So the usual approach is first you calculate the actual cross product and then you do the dot product. The direct approach is a shortcut, just not exactly a shortcut, just to reduce one step. Actually that's the Cartesian form, but I'm not giving you that as a Cartesian form. What you do is What do we do in dot product? Multiply I with I, j with j, k with k, and remove ijk. Same thing we'll do here. So multiply I with I. So minus 2 and 1. So minus 2, minus 1 and 1. Minus 1, 0 with k, 0. Minus 3, 1, 5. Minus 1, 2, 5. Actually, you can write the same result directly with the Cartesian form, but again, you have to learn another form. Okay. So you have to check whether this is coming out to 0. Just open the denominator, you will get it 0. Okay. You can open the denominator, it will come 0. Okay. All right. Next is angle between two planes. Now, literally planes, yes, some planes will intersect, and then of course they will have some angles between them, but the point is, how do we literally calculate them? Okay, so I will give you one simple figure, okay, to get the idea around it. So this is the situation, two planes are intersecting, there is some angle between them. Now in order to get the angle between them, what I'll do is I'll calculate normal of first plane, I'll calculate the normal of second plane. Okay, and interestingly, the angle between their normal n1 and 2 will be the angle between their plane. So idea is very simple, angle between two planes is angle between their normal. Normal is n1 vector and n2 vector. Okay, so how do we calculate angle between two vectors? Same thing, cos theta is dot product divided by their magnitude. Okay. Done. As simple as that. Again, no need for Cartesian again here also. We'll look for only special cases. What are the special cases? What if two planes are perpendicular? So condition of perpendicular planes. So two planes are perpendicular means their angle between their normal is also 90 degree. So two normals are also perpendicular. So two normals are perpendicular if their dot product is 0. Again, from same thing from the vectors. Two vectors are perpendicular when the dot product is 0. All right. Let's do example of it. One question will do. The question is saying find angle between the two planes. Okay. So angle between two planes is angle between their vectors. What is n1 vector here? Components of x, y, z. 2i plus 1j minus 2k. And 2 is 3i minus 6j minus 2k. Okay. We got the two vectors. Now calculate angle between them. Cos theta is equal to n1 dot n2 mod n1 mod n2. Dot product 2, 3, 6, 1 minus 6 minus 2 minus 2, 4 upon magnitude 2 square 1 square 4 4 1 9 3 3 square 4 9 9 plus 6 square 36 plus 4 40 49, so 7. Basically 4 by 21. So theta we can say is cos inverse 4 by 21. Yes, weird value, but that's the answer. Okay. So again, if you look at vectors, all you have 3D basically. If you look at 3D, you will see that it is clearly application of your dot product means whatever learned basics you have learned in vector form. This is just an extension of it. Okay. Now next is distance of a plane, distance of a point from a plane. Okay, very important form. Remember, we calculated distance from origin. We use the idea that the normal vector should not be there. There should be normal, unit normal vector. So in order to do that, we used to divide it by magnitude. Let's look at the form. Again, there are two forms, vector form as well as Cartesian form. In this particular thing, I'll suggest that you use the Cartesian form rather than vector form. So let me get the figure first. The figure is weird, so I'll draw it myself. So let's say you have a plane, okay, and you are supposed to you are calculating a distance from a point, let's say here. So in order to calculate distance, you will calculate the distance perpendicularly like this. Okay, this is some point x1, y1, z1. Okay, the equation of plane is given. What's given? Given is given plane, that will be some ax plus by plus cz is equal to d. And don't get worried if it is written in capital, still same thing. Okay, all right. Now in order to get the distance, it is pretty much same as getting a distance of a point from a line. If you can recall, again, related with line, it's simple that way. First of all, get the equation on the left, all the components on the left side, means d also should be on the left. What we used to do is we put this coordinate in this equation. That means a x1, b y1, c z1. Replace the value of x, y, z with x1, y1, z1, the values. Okay. Minus d, get everything on the left side now. And then denominator of a square, b square, c square. This is exactly like distance of a point from a line. Same form. Okay, so try to relate it with the distance of a point from a line. Okay, so let's calculate a distance. So a point is given. This is the point. Okay, x1, y1, z1, and the equation is given in the Cartesian vector form. So how do we convert it into Cartesian? Less than 10 seconds. Replace I with x, j with y, k with z is equal to 4. Okay, now you got the equation, and get the 4 also on the left is equal to 0. Put this point in this equation. So distance is mod is because distance cannot be negative. So 6 into 2 plus 5 into minus 3 plus 2 into z is minus 3, and minus 4 is also there. Minus 4, and denominator component squares, x 6 square minus 3 square plus 2 square. Okay, a square, b square, c square, that's this. So 12 minus 15 minus 6 plus 4, minus 4 actually. Minus 4 upon 36 plus 4, 47, it will become 7. Okay, in the mod. So that becomes minus 3 minus 9 minus 13. Okay, so it is coming negative 13 by 7. Mod will make it positive. So distance is 13 by 7 units is the distance. Okay. So you need to learn a lot of forms in this. What you do is out of these notes, what you do is just note down the forms and write it on a piece of paper, one single A4 paper. All the forms should be written for the lines as well as from the plane. On the front part you do the lines, second part planes on the other side. Okay. So as such 3D is not tough. The reason 3D is sometimes tough because sometimes the questions are typical because of the visualization part, and sometimes it's difficult because of there are a lot of forms and you have the tendency to mix them up. Okay. Last thing, I think this is pretty much the last form. So you need to calculate angle between a plane and a line. Okay. So all right. So this is a situation. Okay. You need to calculate this angle. Okay. Because this is the angle between the line and the plane. But clearly we know we cannot directly calculate because the direction of plane is actually given by the normal. So let's calculate the angle that is with the normal and then do the 90 minus theta of it, because we need that angle. Let's call this angle as some alpha. Okay, in order to avoid the confusion, let's call this as alpha angle, and we are supposed to find angle between line and plane, that will be represented by alpha. Okay, so your plane will have the equation ax plus let's use the vector form this time. Vector form will be helpful. R vector dot n vector is equal to d. Your line will have the equation r vector is equal to a vector plus lambda times b vector. A is just a passing point, doesn't affect. So in order to get the angle between line and normal, first of all let's calculate cos theta. Okay. So what is cos theta? Cos theta is the we are trying to calculate this cos theta, angle between normal and this. So we'll do the dot product of normal vector, and this direction will be given by b vector. So cos theta is equal to b n dot b or b dot n upon mod b mod n. But remember, we don't have to calculate theta, we have to calculate alpha. So what I'll do is I'll replace this theta with cos 90 minus alpha. Okay, because forget this, I'll say theta plus alpha is 90 degree and we are supposed to calculate alpha. So this is b dot n upon mod b mod n. So what is cos 90 minus alpha? Sin alpha. So sin alpha is equal to b dot n upon mod b mod n. Okay. This is the formula for angle between line and your plane. Okay. Remember, alpha is the angle between line and plane. So instead of cos, we'll calculate sine in this. Okay. And I've shown you the working why it is coming sine, because we have used the property of cos 90 minus alpha. Okay. Let's do the last example based on this. So you have to find the angle between a line and a plane. So what do we really need? B vector, that is in the denominator, and the n vector, that are the components. Write down the b vector first. B vector is 2i plus 3j plus 6k. Write down the n vector, that is 10i plus 2j minus 11k, and then use sine alpha is same formula of dot product b dot n upon mod b mod n. That's it, and we'll calculate the alpha. Dot product, so 20 plus 6 plus, not plus, minus 66 upon magnitude 6 square 36 40 49, that is again come 7. The magnitude of this is, this will be typical, square root of 121 plus 4 plus 100, 225 15 it will come. So 20 na, so this is 31. So, and this is again in mod. This is another, again mod is another mod is there. Okay, I forgot to put the mod. Reason being, we'll calculate the acute angle only. So we'll make sure that the dot product is coming up effectively positive. Okay. So this is coming again, let me check. I put wrong here once again. This is 10, my bad. Hmm. 1026 was there. Now it is correct. Mod. This is coming out to be minus 60 minus 40, so 40 by 7 into 15 mod, that is sine alpha, so that is coming out to be 8 by 7 into 3 21. Okay, actually it will come negative, but mod will make it positive. So sine alpha is this, so the angle alpha is sine inverse 8 by 21. That's the answer. All right, we have done every single form now for the plane, and we have done the examples based on each form. We'll practice some questions additionally if required. Okay. All right, so a lot of forms are covered in this class, so go through those, revise those, make short notes of those. Okay, that will be very helpful. Okay, that's it from my end. See you in the next class. Good day everyone. Bye.